Hello, welcome to everyone in this video. This is the lecture number 14 on digital electronics. Today I want to discuss about the computer organization. In that there is input output device, data storage, that is idea of RAM and ROM, EPROM, then computer memory, memory organization and addressing, then memory interfacing and memory map. We will be cover up this portion. You can see this is the total syllabus. In the previous lecture we cover integrated circuit, number system, digital circuit, then implementation of different circuit, data processing circuit, sequential circuit, register and counter we already discussed in previous lectures. Today we want to cover up this portion, that is computer organization. So let's start. You know that there is various inputs and output device in the computer. That is the signal inputted to the computer is like that is keyboard, mouse, joystick, scanner, web microphone. These are the device by which you can inputted the signal into the computer. In the other side, the signal which are outputted from the computer is like that: monitor, printer, speaker, headphone, projector, etc. Okay, so these are the input device, these are the output device in which we use the different uh, digital to analog circuit or the digital uh, circuits, right? Now we want to know that is the flip flop. Flip flop is a single bit storage, because you know there is state where they store the previous output. So for a single bit storage, you can say flip flop is a single bit storage. After that, we know about the register. We store the data, and the combination of register you get the memory. Right? There are three types of memory: primary memory, cache memory, secondary memory. Okay, and here is the table between the bits, bytes, level units in the binary system. Okay, bits is 0 or 1, 4 bits is level, 8 bit is byte, to the 10 byte, this b is byte, is known as 1 kilobyte, to the 10 kilobyte is 1 megabyte, then 1 gigabyte, petabyte, petabyte, zettabyte. Okay, and you know that is the primary memory has a high speed but its memory capacity is low. Traces memory is more speed than primary and low memory capacity, but secondary memory has low speed but its memory capacity is high, right? So during the operation in the computer you use the primary and traces memory, and for storage you use the secondary memory. Okay, and primary memory have two types, RAM and ROM. RAM is the random access memory, or ROM is the read or write only memory. Random access memory is the static random access memory, SRAM, and there is dynamic random access memory, DRAM. SRAM is made by flip-flop, DRAM is made by transistor and capacitor. That's why SRAM is faster and less power consumption than DRAM. RAM is volatile memory, that is after shut down the computer, it's just remove the information from this. So during the operation RAM is used. ROM is non-volatile, it prevents some data, does not lost after shutdown. But you remember that is ROM is permanent store, but its capacity is low. For huge amount of memory you need to store, then you use secondary memory like hard drive, pen drive, etc. Okay, and ROM has different type: marks programmable ROM, programmable read only memory ROM, erasable programmable read only memory only memory. And this is two type: electrical erasable and electrical alternable. So ROM data can be changed electrically or uh, different process. So this is programmable and erasable also, ROM. And so RAM is volatile, ROM is non-volatile. Main difference. Chassis memory is the use for high speed computer, where the this memory is very low but its speed is the high. Actually the CPU speed is high, so if you wants to take from the secondary main memory, so there is mismatch in speed. That's why cache memory is used to matches the speed. Okay, secondary memory actually used for data storage, its speed is very low, For future storage, you use the secondary uh, memory, that is hard disk, pen drive, SD card, memory card, etc. It is slower than primary, but its memory capacity is higher than primary. And the memory organized, that is, you see the memory is organized like that. That is, register flip flop has very high speed, but cost is high, memory is low. If you go to the hierarchy like that, at the bottom the size of the memory capacity is high, size is larger, access time is large, but the cost is low and the speed is low. Okay, and these organized are connected by a bus, that is the connector, which is known as data bus, address bus, control bus. Data bus is bidirectional, where the data is informed by caches memory. Data is transfer. Address bar is unidirection because it's only take the information of address. Actually, why the data store in the memory, the address of this data store actually go to this by this wire, and the control bus which control this is also bidirectional, which is control signal for computer's activity, which activity you wants to this control signal actually passes through this wire. And memory interface is that is the input output signal are connected with the memory. You can see this is the caches memory is connected with that one. And memory map, you can see there is two type: isolated input output and the memory mapped input output. Isolated means the address bus, data bus connected with memory as well as input output device separately, but the memory mapped, that is the input output device connected with the address bus, control bus through the memory. It is a separated, this is a through this memory. So there is difference written here, you can read down this thing. Okay, so that's it for today. Thank you.